My name is Mickey Wiesner, and I'm the maker of Big Kibo. I'm also a researcher at the DevTech Research Group at Tufts University, where we focus on new technologies for early childhood. Educational robots and programming languages have been designed since the late 1960s, with the goal of teaching children to program and use computational thinking. Many of these technologies are designed to be played with in front of children, either on the floor or on a tabletop, and as a result, are relatively small. However, at times, children naturally gravitate towards playing with large objects. You might be familiar with couch cushion forts or large cardboard constructions. I wanted to know if it's possible to leverage this large-scale fantasy play that children naturally engage with in order to get them interested and excited about playing with robots and learning to program. Using the Kibo Robotics platform developed here at DevTech as a model, I built my own robot which copied the functionality and programming language of Kibo, but is 109 times bigger. I then set out to answer the question of how are children's experiences with Big Kibo different from Kibo, with an exploratory study that invited 6 kindergartners to play with Big Kibo and Kibo separately. To analyze this data, I created my own developmental model which breaks programming of the Kibo Robotics platform into 4 distinct stages. I also operationalized the 7 powerful ideas of computational thinking put forward in Professor Baer's new work as they applied to the Kibo Robotics platform. I used these 2 tools as lenses to investigate whether or not the size of the robot changed the way children programmed or engaged in computational thinking. I also analyzed their play for structure and content. What I found was that in this study, children engaged in computational thinking and programming in very similar ways between both robots. What was different is the way that they played. When playing with Big Kibo, children created deeper, more complex narratives than when playing with Kibo. Playing with the Big Kibo allowed children to make crafts and features larger than they usually engage with to go on and be attached to Big Kibo. These features can do real work in the world that Kibo's size and power don't allow for. For example, making a towing hook to pull children's stuffed animals. When designing for early childhood, it's important to find many pathways for children to get to the same concepts. Big Kibo is an example of a new way for children to engage with computational thinking and programming. That is, through play with large objects. This study has generated many questions. What else could be learned if we repeated this study with a larger sample size? What would a developmental model of computational thinking look like? What is the role of play in children's learning computational thinking and programming? What is the role of the activities we present to children in their learning of programming and development of computational thinking? Big Kibo is the first step in bridging the gap between digital playgrounds designed at DevTech and those in the world.